All right, so geometry, we're going to talk about section 8 to special right triangles. Now, this topic is confusing to some, so I get if you don't get it right away. But these are meant to be helpful tricks, these special right triangles. In addition, if you take pre-calc, the angles that we talk about here are going to be used quite often in pre-calc. Okay? All right, so there are two special right triangles we will talk about. The first one here is a 45, 45, 90 triangle. Now, before I explain this, I'm going to go to Desmos geometry, and we're going to do a little Pythagorean theorem activity. All right, so here's Desmos geometry. So what I want to do is I want to create a what's called a 45, 45, 90 triangle. Now, a 45, 45, 90 triangle can be built from a square. So I'm going to make a square real fast. I'm going to pause the video. All right, so here's that square. So if I draw one of the diagonals, okay, you will see that if I measure the angles, this is of course going to be a right angle, and then these two angles should be 45 and 45. So there's my 45, 45, 90 triangle, okay? So if I want to talk about the side lengths of a 45, 45, 90 triangle, well, the first thing you should know is that this triangle is isosceles, right? So these two outside lengths should be the same. So if we label that 4.18, 4.18. So they are the same, okay? And then the length of your diagonal is a special relationship with these two sides, okay? If we take a leg and multiply it by the square root of 2, we are going to get the length of this diagonal. So watch this in our calculator. 4.18 times the square root of 2. So Desmos graphing calculator, 4.18 times the square root of 2. Root of 2. That's 5.91. Watch what happens when I measure this diagonal. And look at that, 5.91. It's amazing, right? So in a 45, 45, 90 triangle, this is the relationship that always occurs. This side length can be called x. This side length is also x, and then the hypotenuse is x square root of 2. And this relationship always holds for a 45, 45, 90 triangle, the isosceles right triangle. So if I come back to our notes here, not this one, this one. So here is what we're talking about today. 45, 45, 90 triangle. So in any 45, 45, 90 triangle, the legs are congruent. And the hypotenuse is the length of the side length times the square root of 2. And that's exactly what it says right here. The length of the leg times the square root of 2. So be aware of this. All right. So whenever you see a 45, 45, 90 triangle, think these labels. The other one is called a 30, 60, 90 triangle. Again, we'll go back to Desmos geometry to make this happen. So a 30, 60, 90 can be built from an equilateral triangle. So let me make an equilateral triangle real fast, and then I'll come back. Okay, so here's our equilateral triangle. And if you draw a segment perpendicular straight down, perpendicular to this side from the top, I'm going to create a segment there. I'm now going to hide this line. I have just created a 30, 60, 90 triangle. Let me prove it to you, right? Let's measure the angles. Of course, that'll be 90 because we just made it perpendicular. In a equilateral triangle, all three main angles are congruent. So 180 divided by 3 is 60. So that angle should be 60. And then this angle is bisecting the top, or I'm sorry, this segment is bisecting the top angle. So that 60 degrees split into 2 will be 30. So here's the first relationship. This leg right here we call the short leg. I'm going to make a segment. Let me measure that short leg. There. 3.67. The hypotenuse should be roughly 2 times that short leg. So let's go into Desmos graphing calculator. Let's go 2 times 3.67. Not and, 2 times. 7.34. So let's see. 7.34, there you go. And now this, we call this the longer leg, has a special relationship with the short leg. It's going to be the square root of 3 times the short leg. So if I come here, square root of 3 times 3.67. 6.356. 6.36. There you go. Rounded to decimals. And that is a 30, 60, 90 triangle. So first off, we have to understand where the short leg is. This is your 30-degree angle. The 30-degree angle points to the short leg. That's the short leg. Okay, call this X. And then the hypotenuse, which is across from the 90, is going to be 2 times x. And the long leg, which I always say is the third side, but the longer leg, is going to be x times the square root of 3. Always and forever for any 30, 60, 90 triangle. Okay. So if we take a look here, back at our notes, here it is presented to you. So here's my 30, 60, 90 triangle. Again, the short leg we call S, and we find the hypotenuse from the short leg by multiplying it by 2. And we find the log leg by taking the short leg and multiplying it by the square root of 3. Always and forever. 30, 60, 90 triangle. Okay, so I'm going to stop this video, and I'm going to make a video doing a couple problems from Delta.